Good afternoon, everyone. Thanks for joining us. My name is Ankur Kotwal, and I'm an Android developer advocate from Sydney, Australia.
Hi, I'm Chris Broadfoot. I work on the Google Maps API team, also in Sydney. And today we're going to talk to you about the Google Maps Android API v2, which to some of you may be quite new. It was released since last year's Google I/O, and it was released late last year, 2012.
So what we really want to show you today is cool ways that you can use the API to really not just build basic maps or include basic maps, but really rich, detailed maps. So we're going to show you some of the capabilities of the library itself, but then also show you how you can mix in Android sensors and Google Maps web services.
Yeah, so the format of this talk is 3 demos, and then we'll take a deep dive into each demo and show you how they were built and the interesting aspects of each demo.
So why don't we start with the first demo?
Yeah.
All right, so you'll see on this app, we have 2 maps on here.
Wait, Ankur, 2 maps?
Yeah, sorry, I should explain that. We said Maps for Android API v2. The 2 actually means you can have 2 maps.
Dude, we went through this.
Oh, sorry, no. What it means is that you can have as many maps as you want. This is something developers have been asking for a while, because with the old API, you could only have 1 map at a time, right? Well, now you can have as many as you want. Obviously, you want to tailor your user experience accordingly. So having 15 on there, probably not such a good thing.
OK, so before we get into it, do you want to explain what we're getting at here, what the demo?
Yeah, sure. So have you ever wondered how long it takes you to get from the airport when you arrive to take a flight to the point where you get to your destination? Well, it turns out that if you live in Sydney, anywhere you go is a long, long time, mainly because of the flight. But what we did is we were curious about this information, and we built an app which kind of shows us our journey through the airport, and we wanted to tell this story using maps. So going back to it, you see 2 maps here. On the left-hand side is me. On the right-hand side is Chris. We've actually both arrived at Sydney Airport, but we got dropped off by our cabs at opposite ends. So I was at the northern end, and Chris was at the southern end. So let's start the story. And the best way to start a story, actually, is to move the distractions out of the way. So Chris, we're going to get rid of you.
Excuse me.
We're going to focus on me for a minute. This is me walking through Sydney Airport, and I've just walked inside Sydney Airport, and the first thing I've done is stop to see the screens to see where I can go and check in.
Can you explain this green trail that's behind you? Is that a realistic representation of what actually happened?
No, I can promise you I wasn't leaving a green trail behind me as I walked through the airport. That's a polyline. And what I'm doing is using the polyline to visualize my path through Sydney Airport.
OK, good to know.
OK. Do you have any more questions?
Yeah, I will.
All right, so this is me walking to counter D. And
oh, there's me. There's me.
Just as I arrived at counter D, Chris and I ran into one another, where we sort of pretty much checked in at the same time. So
and what happened next?
We then started to make our way through security and immigration. So
well, we've merged. Okay.
We have. So we are now one.
So this is a new feature that we released in the latest version of Google Play Services, and that's set icon. Now, that might not sound like very much, but it means that you don't have to swap out your marker objects just to change the icon.
Yeah, set icon. Woo! If you've ever been through Sydney Airport on a weekend through immigration and security, you probably know how horrendously slow it can be.
Almost as bad as LA. Oh, sorry,
actually, not as bad as LA. Nothing's as bad as LA.
OK.
Anyways, we went through security, and we're going to make our way through. And you'll notice on the bottom right, there's a little icon that shows us walking.
So is this the new activity recognition API?
That's right. So as you notice here, every time we move on the map, we're showing a little icon to represent that we were walking. That information was actually gathered through the activity recognition API that was also launched in Google Play Services 3.1.
So speaking of walking along the map, I noticed that we're animating these markers along the map, and that's not exactly a feature of the API. There's no walking of markers.
Yes, that's right. We are actually moving the marker without creating a new marker every time. We're going to show you some code on how we animate these markers. But for now, what we'll do is continue the story. Sydney Airport, once you get through security, they force you to go through duty free.
It's very confusing. I feel like I'm in an IKEA or something, but there's just perfume everywhere.
And frankly, even though we were doing some shopping, there's only so much perfume you can buy. So we finally got through the stores and got out. And at this point, we realized that we actually have more time for our flight than we first expected. So we thought, well, what should we do to kill the time? And
Well,
we did
there was really only one option.
Yeah, I mean, it's the Australian way.
Yeah, just drink beer.
We went to the lounge. And there's that icon on the bottom right-hand corner again. But this is us traveling to the lounge. We sat down at the lounge, had a good chat, and although we were only going to stay for one drink, we stayed for a few more, and then a few more after that. And then we heard an announcement.
It was our names. I heard our names many times.
Yeah, it was our names, and they were telling us that they were going to throw our luggage off the flight if we didn't get to the gate quickly. So we panicked, and we started running to the gate.
You panicked, I just followed.
You can see us now running and moving along the map a lot faster. You can see the animations have sped up here, and we've also added this yellow glow to kind of accentuate the sort of stress that we were feeling.
And so that's just a view on top of the map, right?
It's just an image view.
Right.
The other thing that yellow glow serves, the purpose that it serves, is that it sort of adds a bit of a haze over the map. And frankly, that's what we were seeing after our time at the lounge. Anyways, the good news is we got on our flight, we took off, and we were able to make it here on time to give you this presentation. And we got to San Francisco.
I think next year we should stop at Hawaii.
Yeah, I've never seen the lounge in Hawaii.
We're just going straight past there.
Yeah, absolutely.
Okay.
So here we are, San Francisco Airport, landed safe and sound. And I just want to point out here this beautiful map. It's an indoor map of San Francisco Airport. And even in Sydney Airport, it was an indoor map that was showing us as we were traversing through the various sections.
So this is a new feature in the Google Maps API. And yeah, it's on by default.
All right, well, why don't we talk about how we put this together? And really, we can't talk about it without talking about Google Play Services. For many of you that have been in presence at I/O, you probably have heard a bit about Google Play Services. But for those of you watching on YouTube, Google Play Services is a way that APIs are delivered to users' devices. So it's an APK that gets installed alongside with the Google Play Store and automatically updated. So the fantastic news for everyone in this room is all of the demos we're showing you today, they're using APIs that are already available to all your users, Android 2.2 and up, or Froyo and up.
Yeah, I mean, the other great thing is as the Google Maps API team keeps making improvements, so bug fixes, enhancements, and new features, your users automatically get that functionality and your app automatically gets better. So you don't have to redeploy your app, your users don't have to upgrade, everything just gets better.
And the good thing is you don't actually have to, well, you mentioned you don't have to redeploy your app, but in terms of new features that get rolled out, you can incorporate them straight away. As soon as we talk about it publicly, they're available. All right, map fragment. I think there's probably many of you in this room that have had angry blog posts about us releasing map fragments. We could only have one map at a time. So I'm hoping we don't have the same angry mob this time that we had in previous I/Os. The good news is once you've incorporated the Maps API library in your app, and that's just by including the static lib for Google Play Services, the thin wrapper, you just need an API key, and then you can use map fragments straight away. So here is a layout, and all we've done is dropped 2 map fragments in, and we're good to go.
There's also support map fragment if you need to support ICS and below. Oh, sorry, no, below ICS.
Yeah.
Of course, ICS, you can use map fragment directly.
So by default, map fragments give you the full capability of maps. So you get outdoor mapping, indoor mapping, you get all the gestures.
Yeah, so by default, the map is fully featured. You don't need to enable gestures or any other features. You get the default controls. You can easily enable the My Location layer, which we'll show you a little bit later on.
Obviously, as developers, you can turn those features off if you want to have a very fine-grained control for your users, or if you want to provide your own zoom buttons or My Location buttons. So we give you capabilities to do that. Let's talk about markers and animating markers. So let's look at some code. Chris was asking how we moved those markers around. Basically, what we're doing is periodically setting the position on our markers. So we're using a handler to do that. And what we do is we grab the start time when we want to kick off a marker animation, And then when our handler executes, we work out how much time has elapsed and adjust the position of the marker accordingly. I want to make a special call out to this thing that we're using called an interpolator. We're using a linear interpolator, so if in effect we're moving the marker linearly across that time. But you could use a different interpolator, something like an accelerate-decelerate interpolator, which allows the marker to kind of start very slowly and speed up and then slow down once again.
So this is particularly useful for camera transitions, but yeah, also for animating markers.
Yeah, so if you wanted to use a different interpolator, you might have a car moving along a map that speeds up and has to brake really hard, and you could do that with an interpolator. All right, so once we've sort of calculated the values we want to set, we just go ahead and set the position of that marker. And just before we get out, we reinitialize, or we tell the handler that you need to run again in 16 milliseconds. Now, you may be thinking that 16 milliseconds seems like a magic number. Well, it's actually not. It's a number that you'll see time and time again, because Android devices typically render at 60 frames per second, which means you get 16 milliseconds to render each frame. So the reason that number 16 milliseconds is here is because we're asking the handler to run again for the next frame. Now, Chris, you mentioned the line that was following me. That was a polyline, but we have other types of shapes that we can draw as well.
Yeah, so for those of you not familiar with polylines, they're essentially a list of latitude and longitude points. And polygons are very similar. They're a list of latitude and longitude points once again, but enclosed. So polygons can actually have a fill because they're enclosed, and they can also have holes. Oh, I haven't seen this slide before. Ankur, that's a very strange geographic feature.
That's just a bug droid, Chris. You should know this.
OK, so the holes you can see here are represented with the eyes. And obviously, you can have different styling. So you can see here the bug droid's body has a black stroke, and his antennae, I think that's what they're called, or ears, don't have a stroke.
So for the eyes, they're actually truly holes. We haven't put another polygon on top that's a different color. It's actually a cutout of a hole, and you can do that with the API.
Exactly. So we also have circles, which are a special case of polygon, where each point is an equal distance from the center. So you just specify a center and a radius. But remember that this radius is specified in meters. So this is a feature on the surface of the Earth. It's not specified in screen space.
All right. Now, I want to make another mention of indoor maps, because really they allowed us to have such a rich story to tell in an indoor location like Sydney Airport. Without indoor maps, Sydney Airport and San Francisco Airport would have just been gray or brown boxes. So indoor maps are great, and as we mentioned, you get them by default. As developers, of course, you have an API that allows you to turn off indoor maps if for whatever reason you don't want to show indoor map locations on your map. And the other thing to keep in mind is that if you have multiple map fragments, we only show indoor maps today on one of the fragments at a time. It is based on the first map that gets drawn, but that's OK because we have a nice API that allows you to control that. So all you do is tell all of your map fragments to turn off indoor and turn it on for the one fragment that you do really want to show it on.
And the other thing you may have noticed in Sydney Airport, there were 2 levels. So the user can change between the levels. That's there by default as well.
All right, activity recognition. This is one of my favorite new features of Google Play Services 3.1 because it allows developers to register for callbacks when the activity that the user is taking changes. So you can find out whether the user is still, whether the device is tilting, or you can find out directly whether they're on foot, they're on a bike, or they're driving. Now, this is really, really useful information because it can affect the way you might want to present your app to the user. If you're showing a map and you can tell that they're in a car that's moving fast, so they're driving, well, hopefully not driving, but a passenger in the car, you can zoom out your map so that it's not animating too quickly, right? And you can do that passively. These are the types of delightful experiences that your users will maybe consciously notice, but definitely subconsciously it'll be a better experience for them. So in Google Now, at the end of the month, you actually, many of you have probably seen this card that tells you this is the activity that you undertook over the month. We are actually using the same APIs, the activity recognition APIs that you all have access to now as well. So the other thing I want to mention is that there was a great talk on activity recognition called Behind the Blue Dot. And for those of you in this room, it's already happened this morning. But you can go and watch it on YouTube. So for everyone, if you haven't seen it, it's a really great talk on how to use the API as well as how they built it. And finally, we also have a code lab tomorrow that shows you how to implement activity recognition in your apps. And we can't wait to see what you can do with it. All right, let's do one more demo. This one is called a tour of San Francisco. And the reason I want to show it off is because this showcases my favorite feature of the Maps API, and that's the camera.
So this,
sorry. No, you go ahead.
So this demo is demonstrating that you have full programmatic access to the camera. You can see that there's beautiful 3D buildings, and we're just transitioning between these different camera viewpoints very smoothly.
So all we do here is we animate the camera, and we randomly assign a tilt and a bearing. Where you'll notice that when we move from location to location, we get this beautiful zoom out and zoom back in. The 3D buildings just look marvelous. The maps themselves are vector maps, so they always stay sharp. And it just generally provides such a nice cinematic experience. It's like doing a kind of flyover through San Francisco.
So it's worth noting that this demo is just showing the programmatic access to the camera, but your users have full access to these changes in camera as well through the use of gestures.
All right, let's switch back to slides. In general, camera on Maps API, awesome. Make full use of it. As you include it in your maps, don't think of your map as just something flat. Think of it as how you can make it more tactile. Let me just show you some code on how we are animating the camera. Sorry, click, there we go. We first create a camera position object, and this is basically saying, where do I want the camera to be? We're able to specify a location, tilt, bearing, and zoom level as well.
Now, be aware that you can specify the zoom level as a float, so you can actually have a fractional zoom. So you're not limited to discrete zoom levels.
Yeah, it's continuous.
Yep.
Now, the other thing we can do is actually chain animation. So in our demo just then, what we were doing was once we got to a destination, we were moving it to the next one. So you can do it with a listener like we have here. When we pass it in, it lets us know when an animation is complete, so we can trigger the next one.
So there's also an on-cancel callback, and this will be triggered, for example, if the user is panned away while an animation is in progress. So if you were expecting to do something when the animation is finished, maybe you could do something else if it's been cancelled.
All right, let's have a look at one more demo.
So Ankur, have you ever traveled to a city and had absolutely no idea what to do? Maybe you've woken up in the hotel and you've got a day off.
That's actually the type of traveler that I am, Chris.
Disorganized?
No, spontaneous.
Okay. So Ankur and I thought it would be cool to build a demo to address this use case. So once again, this is just a demo. It's not app quality.
And so here we are in Moscone, and oh, bummer. There we go.
So we had an interesting location there.
So the first thing we did was actually ask for location, and the map started off with our location. It took us took a moment to get that, but now that we have it.
Yeah, so we're using the My Location layer. Now this is just one flag that you set, and you get the My Location button, which you can see in the top right. And when the user presses that, the map is panned over to their current location, and a blue dot is displayed on the map directly.
Now I noticed, Chris, that we have some red markers on here.
Yeah, so these points are coming through the Places API, which is a web service. So you just fire off an HTTP request, and you get back all this interesting location data. So if I just click on one of these, you can see that we're getting some interesting places around here. A lot of hotels. All hotels. OK, good. And in the info window, which is displayed above the marker, we're just showing the place name. Now, info windows are fully customizable. You can have your own custom views through an info window adapter, but here we're just showing the place name. Very simple.
OK, I also noticed that there's this blue circle that's sort of growing out from the center.
Yeah, exactly. So we're just using a circle, which we talked about a little bit earlier, and we're animating the radius of that circle.
And this is a neat visualization trick because it's actually showing us how far out from our location we're searching.
Yeah, so this is just showing to the user that the place of search sort of is contained within that radius. Just a nice visual indicator. And in fact, I've added a long press listener. So if I long press over here, the place of search then moves over to that new location, and the user can see that they've got some feedback that this is the new center of the search.
So why don't we pick a place that we might want to add to our itinerary?
Okay, so I'm a big fan of the marina. So let's go over to Fisherman's Wharf. You can see here that we've painted a line from our location, which was provided through the location API, to the location that I've just pressed.
Now this is a polyline, but there's something interesting about it because it's not a straight line from where we started.
Exactly. It's actually the path, the recommended path for walking. And this data came from the Directions API, which again is a web service.
Now, I'm also noticing that we have some extra information here on the left-hand side. Not just the name, but we have the distance and the time that it would take us to do this.
Yeah, precisely. So this information also came through the Directions API. And you'll notice that the sidebar says 2.1 miles, 43 minutes. These values are localized from the API, so you don't have to worry about localizing inside your app, which is very handy.
Okay. Now, there's this button here, Magic Camera. You want to show us what that is, Chris?
Oh, Magic Camera is my favorite. Okay, so you'll notice that the map is moving around a little bit as I'm holding the device.
I thought that's just because you're nervous.
I am a little nervous. Yes, that's true. Okay, so as I hold the device up, you'll see that the map is panning, sorry, not panning, it's tilting and zooming at the same time. Now, once again, I'll just put the tablet down, and you can see that it's zoomed out and is flat once again. Okay, so let's go back up. And you can see that the 3D buildings start to appear as I've brought the device up. Now you can imagine that your user has picked up their device and they're sort of looking out to the world in front of them.
So this, if you're thinking about it from the use case that we started with, an itinerary app, this is a nice third-person view. We can see what's in front of us. If we were to visit this location, what's in this direction?
Exactly.
So speaking of direction, what's in that direction?
Okay, so let's move the tablet over there a little bit. So once again, we're using the sensors in the device to detect the position, the orientation of the device in the real world, and using these values to alter the map's camera. So it's a little awkward that if I was turning here, then that's turning my back to you. But you can see the city behind us. And as I keep panning around, let's put the tablet down. So this is almost as though the user is going into planning mode. You can imagine someone laying down a paper map and spreading it out all in front of them. Okay, once again, I'm going to long press. Let's head over to Alcatraz. All right, so we're going to get walking directions over there, Ankur.
Whoa, hold on. That was interesting because we asked for walking directions, but from our blue marker, we went right and then up towards it. What's up with that?
So this is actually us getting onto a ferry. Because there's no way of directly walking over there, the Directions API has added a step for the ferry itself. And this is also reflected in the time. You can see that it takes 29 minutes over 2.7 miles to get over there.
So you're telling me the Directions API not just does walking and driving, but we get public transport information as well?
Exactly. So let's hop into Magic Camera on Alcatraz, because I think that's pretty cool. And you can see Alcatraz there and the path that you use to walk up to the top.
It even has the path from where we got to the ferry terminal up to the actual entrance of the island.
Yeah, exactly.
Awesome. Let's see how we put this together.
Okay. So let's talk about Magic Camera, because that's one of my favorite things about this demo. Okay, so first of all, let's talk about the sensor data. We're using the rotation vector sensor. Now, Ankur, you did a talk at last year's Google I/O about Android sensors. Can you tell us a bit more about this sensor?
Yeah, so the rotation vector sensor is an interesting one because it doesn't map directly to a hardware sensor. It actually aggregates multiple sensors. It uses the accelerometer, the gyroscope, and the magnetometer. So the nice thing about it is that you get some very nice data because it's algorithmically putting that together and presenting it to you in a nice way. But even better than that, you don't actually have to check whether that particular sensor exists. Because if the gyroscope isn't on that particular Android device, this sensor will, because it's a fused sensor, it'll still give you back data. It'll do the best that it can do with the sensors that it has access to. So it actually was, the rotation vector was introduced in Android 2.3 or Gingerbread, but it's really cool from that sense.
Yeah, I've also noticed that the data that comes back from this sensor is quite clean, so you only have to do a very small amount of data cleaning on it. So reading from it is very simple. We just simply register a listener with our update interval. So here again, we're using 16 milliseconds to get an update for every frame. And the listener is just very simple. Now, to avoid allocations for every frame, we just pre-allocate an array and keep them as fields. And then for each update, we just populate those fields with the relevant data. So we read the rotation matrix from the sensor's event values, and then convert that rotation matrix into 3 values that are more applicable for most applications. And that's azimuth, tilt, and roll. We're ignoring roll for this demo and just using azimuth, which you can essentially consider to be the direction that north is in, and tilt, which is just the device's tilt.
Yeah, so if you're hearing us talk about the rotation vector and you're hearing words like matrices and it's scaring you, the nice thing is we have some utility functions that handle it for you, and that's all the code that you need to transform it into usable information on maps.
Exactly.
Let's see how we use it.
Okay, so it's actually a very simple mapping between those azimuth and tilt and all of the camera's properties. So we need to clamp the tilt between 0 and 67.5 degrees. Those are the acceptable values for the Maps API. We can just pass the azimuth straight through to the bearing property. We don't need to do any mod by 360 or anything like that. The API handles that for you. And the more interesting thing is the mapping between tilt of the device and the map's zoom. So this is, so we just essentially need to zoom in as the map is brought up toward you, and zoom out when the map is put down. So we start at a minimum of 13, which is zoomed out, and then go up to 18, which is where buildings start to appear.
Now I notice also in this code, Chris, you're doing move camera, whereas in the demo that I did, I was doing animate camera. So can you just tell us a little bit about the differences between those two?
Yeah, so essentially I used move camera, which just snaps the camera into place. Animate camera will transition smoothly into the new camera position, whereas move camera just goes straight there. And so that was useful in this demo because we're updating the camera every frame, so there's no point animating between them.
Now, one of the recurring themes at I/O 2013, has been about how you can delight users. And sometimes delighting users means putting in functionality that they may not actually notice, but is actually significantly improving the experience. So Chris actually had something in his demo that I think really delights the user, but isn't necessarily obvious, and we want to show that now.
And yeah, excuse me if this explanation is a little bit convoluted, but I'm going to talk about this offset camera target. Now you may have noticed, if you just look on the left, this is what happens if we continually animate the bearing around a certain point. So we're pivoting the map around the blue point. Okay, so if you thought about the itinerary demo, if you brought the tablet up and you were looking around, it's not a very good experience because you're seeing all of these markers that are essentially behind you, behind the pivot point. So in the demo, we actually offset the pivot point by a certain number of meters. Now this is just a bit of magic, so that as you put the map down, the pivot point is in the center of the map and not at the bottom of the map. But you can experiment with this a little bit.
So as you're holding it up from a third-person point of view, the right-hand side is actually a much nicer experience because you're seeing what's in front of you, and it's really truly providing you a third-person view. But when it's flat, you do want to see as much as possible. So this is just a subtle tweak, but one that really makes a difference to the experience that the users have.
Yeah, so if you look at the right-hand side map, the blue marker is still the center of the map, but you'll notice that it's actually moving across the world. It's actually moving across on that blue circle. The red point is the pivot point, and that's essentially what we're animating our bearing around. So this is achieved through a function called compute offset, which is just a way of getting another point on the surface of the Earth, a certain number of meters, and with a certain bearing away from another point. So here, the mlat long variable is the pivot point, and we're just offsetting that by a certain number of meters. It's magic. And we're just passing through that azimuth once again, which we used for the bearing. And that's why that point essentially doesn't move as the camera is moving, because those two properties are bound together. So this spherical util is available at github.com/Google Maps. And it's in the Android Maps utils library. And there's a whole bunch of really great functions in there. If you're familiar with our JavaScript API, it's all of those functions. Things like computing the length of the path or the area of a polygon. Okay, let's move on. So let's talk about the Places API. We mentioned that it's a web service. This means that you have to send an HTTP web request to get back the data. So here you send it to maps.googleapis.com. You do need an API key, once again. And you just pass through the center of the search and the radius. We're also specifying a types filter. You can filter over 100 types. For example, restaurants, lodging. We saw a lot of hotels, so maybe you want to filter out the lodging. And also art galleries and things like that.
So let's look at the JSON response that we get back.
Yeah, so you get back a whole bunch of interesting information. In this demo, we use the lat long parts of the geometry. And we just pass those straight through to the marker to display that information on the map. We also use the title. And we didn't use the rating or the reference. The reference is great if you need to go and fetch more data about that place or show some business photos.
We've already talked about animating 1 or 2 markers, but when you have lots of markers, like we did in that demo, when we moved from location to location, we cleared one set of markers, we added new markers, you have to do a little bit of marker management. So we just, this is a topic we get asked about from time to time, so we thought it'd be good to shed some light on it.
Yeah, so because we only had 2 classes of markers, the best way to store that was in 2 different hash maps. We're using, for the place results, just a regular hash map, and it's a mapping between the marker and the relevant place result data. That object could be anything that you like. We're using a linked hash map for the destinations, and this is just because a linked hash map provides consistent ordering as you iterate over them. So that's great if you need, for example, a list. So here we can see that the blue markers are the destinations and the red markers are the place results. So this is useful, as Ankur said, when you need to perform a clearing of all of a particular sort of marker. So here we're just iterating over the place result markers and just clearing them before we clear that map, before we re-add the results from the new array. You can also do great things like in the on-info window click listener or on-marker click listener, go and look up that data. So here, we're actually just ignoring the clicks for the destination markers. But you could imagine switching behavior based on whether a lookup to that map was successful or not. So using markers as keys for maps is really good.
Let's look at how we did the visualization of the search radius.
Yeah, so it's just a very simple animation, animating the radius and some of the visual properties. So in this case, just the stroke of the circle.
And we're using what's called a value animator here. So this is a really neat set of utility classes that we added in Ice Cream Sandwich called the Property Animation Framework. And what it allows you to do is in really trivial amounts of code, you can animate values on your class from a start to an endpoint and provide a duration. You can also provide an interpolator. So you can, in shorthand, it's really nice to be able to use it. So if you're targeting Ice Cream Sandwich or later, the Property Animation Framework is a great thing to use. If you are targeting older versions, you can use a handler to achieve a similar effect.
Yeah, and I believe you could use an object animator if you're only animating one property. So if it was just radius, you could do that much more easily than this even. Okay, so let's talk about the Directions API. This was the other web service that we used in this example. So this is one of a suite of Google Maps web services. So you just pass in the origin and destination. Here we're using the latitude and longitude values for accuracy, but you could also pass through an address, and the Directions API will go and geocode that to this same latitude and longitude. You get back very detailed information, actually turn-by-turn directions and all of the points for those steps. In this demo, we didn't use any of that stuff. We used the distance, the duration, and an overview polyline. As we said, the distance and duration are localized, but of course, because it's an API, you get back structured data, so you get back meters and seconds as well. And this is great for example, if we wanted to display the total time, total walking time, or total distance.
And you mentioned that the values are localized, so obviously in the States we get it as miles.
Yep, or feet as well. Yep.
Most of the rest of the world uses the metric system, so it will be nicely converted to kilometers for you. Yeah,
so this overview polyline may look like a whole bunch of gibberish. I personally can decode it on the fly. I don't know about you guys. But I have released some code in the same utility library that will help you decode this into a list of latitude, longitude points. And you can pass that straight through to a polyline. And you can see here, this is the line that's represented by this interesting string.
So we're not using any of the levels there, we're just using the points, right?
Yeah, exactly. So it's a much more compact format than sending down all of those numbers.
All right. Well, to summarize, today we've talked about the Maps API and just how much control you have over it, things like the camera, things like indoor maps. We've also talked about how we can add other bits of information to provide a better experience for our users, sensors, or even the Google Maps web services. So we hope that this is the type of talk that you can take back and build some apps that really delight us, because we'd love to hear about them.
Yeah, exactly. And so the other one thing that I would like to leave you with, if you guys out there have a map that's using the V1 Maps API or Map View, I strongly encourage you to upgrade to the new API. It's very easy to get going and will delight your users. It's a massive improvement in UI and API over the existing Map View.
And continuously updated.
Yeah, exactly.
Thanks to Google Play Services.
So for those of you here in person, we're running a code lab tomorrow afternoon. And for those of you that can't attend in person, please do go and check out the online resources on both the Android developer resources and the Google Maps developer resources.
Thank you very much for your time today.